Okay, so we'll get started. In the last session, we spoke about loops, right? And we discussed why we use loop, correct? So we said that loop is a mechanism where you need to, or where it is, when it is used to repeat certain block of code more than once. So if you want to repeat a block of code for more than once, loop is used. And we discussed about for loop and while loop briefly, right? And then we took some examples on for loop. We saw how for loop can be used, right? So for loop is used when you know exactly how many times you need to repeat the loop. We'll do one more example now, okay? And then we will jump to while loop, okay? So I'm going to create a multiplication table, okay? So let's see how we do that, okay? Um, my screen should be visible now. And let's say I put, um, let's say we take multiplication table of 5, okay? We'll try to do multiplication table of 5. So multiplication table starts with like 5 into 1 equal to 5. That's what we want to print, right? So we'll say print, okay, format string, right? We'll say 5 into 1 equal to 5, okay? Now, this is good when you have just one number, right? Let me run it and show you. This is good when we have one number. But then when, okay, this number should change, right? This number should change. It should become 1, then 2, then 3, so on. And we also have num here, which represents 5. So, okay, so we can replace this 5 with num, right? So this is how we replace num in format string. And then we'll multiply this with, okay. Now, instead of saying num into 1 equal to 5, num into 2 equal to 10, we can put this in a loop, right? So I can say for I in range. Now here I want from 1 to 10. So what should I give? I should give 1 comma 11, right? Starting value is always what we give. So we want to start from 1 and ending is 1 less than what we give in the range. So range we are giving 11, so it will go up to 10. And increment by default, when you don't give increment, it is default 1, right? So you have range of 1 colon 11. And I'll push this inside for loop. Okay. Now I need to replace this 1 with I, isn't it? So I'll delete it and replace this with I. And this output is going to be, okay, num into I. So let's run this and see what happens. So you get this multiplication table, right? Okay. Now I want to create multiplication table from 1 to 10. So here I'm just using 5, isn't it? So I don't want to use just single 5. I want to create multiplication table from 1 to 10. So what I'll do, I'll put one more loop here, right? Nested loop. And in this case, probably, I will put num here. I'm going to delete num and I'll say for num in range, okay, 1 to 11, and I'll push them inside. So what did we discuss earlier? So first this outer loop will run. Now one iteration of outer loop is like complete iteration of inner loop, right? So the when inner loop is done doing complete iteration, then it goes up again. Then num becomes the next value 2. When num becomes 2 again, I will start from 1 to 10. Goes up, num becomes 3. Again it comes in and I will start from 1 to 10, right? So now if I do this, so you got multiplication table from 1 to 10, right? It starts from 1 and goes all the way up to 10. But let's say I want to print it side by side next to each other. So what I need to do is, see, when you print 1 to 10, it should be printed in this manner, right? But the 2 should come here. 3 should come here. Now I cannot go back after printing 10 lines. I can't go back here. So what I'll do is, instead of printing 1, table of 1 or table of 2 or table of 3, we'll first print like 1 into 1, I mean 1 into 1, and then next we'll print 2 into 1. So we'll first print all the first rows, then the second row, right? So this is what is printing first row. So here I will add this end command, right? Now when I add end command, the first row, it will print all the values in the first row. And once you are done printing the first row, that's when I will go and I'll say print here. So now I'm moving to the next line, next row, right? So something like this. But is it correct? Okay. Now you see this, it says 1 into 1. This is what we want. And then it says 1 into 2. So probably this is not what we want. We want 2 into 1, right? So what I'll do is we'll put I here and num here. Done. So now when you do it, so 1 into 2, 1 into 1, 1 into 2, 1 into 3, this is one table. Then this looks like your 2's table, right? 3's table. Sounds good? Now, see, there's a problem here. Problem is, okay, yeah, now, okay, let's say we give one extra space. Doesn't matter, we can give one extra space. But you see, this is like slanting. Why? See, here you have one digit, so it looks good all the way up to here. The moment you got two digit, what happened? This shifted here. So this 3 is like dancing, right? 4 is even dancing. So it doesn't look good to our eyes. Okay, so what should we do? We have discussed this before. What should we do? Padding. Remember, we did with text, Kohli. We will give fixed spaces. So what we can do is we can say I colon left shift 2, right? So we are assigning 2 spaces for I. Num also will not exceed beyond 2. So colon left shift 2. Now when you run it, do you see that? It has got 2 shift. So something similar we'll do for this one. Now this goes up to 100, isn't it? So we can give 2 or you can give 100. Let's give 2 and see what happens. Because 100 is anyway last. So if 100 is not in line, that's okay because anyway that's the last element. Now you see, it looks somewhat better, right? Okay, now you see, this 2 should have been on the right side. So when you talk about numbers, numbers are always right aligned, not left aligned. Text is left aligned. Numbers are, because if you put 3 here, it looks like tens position, right? So 2 should be above 2, not above 1. So we will make it all right aligned. Numbers are supposed to be right aligned. Okay. Now you see, okay, 9 and then you get 10 here, right? So this is how you can perform your multiplication table. So what all things did we use here? We use loop, not only loop, we use nested loop. Okay, loop inside loop. Okay, then we use format string. Okay, because we have at least 3 variables to handle: num, I, and num into I. And then we also did formatting. Okay, we just use what we learned before to perform this. Sounds good? Okay, so this is how you use for loop. Next, we will jump to while loop and we'll see some examples using while loop. So when do we use while? Yeah. So when, so we use while when we want to repeat something, but we don't know when, right? Okay. We only know condition until which we want to repeat. right? So give me an example. So let's say I want to print hello till the user says yes. Okay. I want to print hello till the user says yes. So print hello, simple. Print hello. Let me move this to next this thing. Okay. Okay. We'll come back here. So this is how you print hello. Now I want to repeat it. Okay. So we put while, right? Because we don't know how many times, but we know a condition when user says yes. Okay. So we'll have a dummy variable called user says, and to begin with, we'll say why. So we know that the user is saying yes. And then I'll say while user says equal to, I'm checking the condition, right? So simple what I did, I assigned y to user says. Now I'm checking user says is equal to y or not. Obviously, it will be y, right? We just know we assigned y. So now when we push this into inside while, this is going to print an infinite loop kind of thing. Because when you run it, what happens? Okay, user says y, goes in, prints hello. Again goes up, checks the condition. It is still y. Goes down, prints hello. Goes up. Again it's y. Prints hello, goes up. So there is no condition to break it, right? It will go on forever. So let's not, for now, let's manually stop it. Now we will print here, okay, the input from the user. As a user, we need to input whether do you want to continue or not. So what function should we use to get the input from the user? Input function, yes. So I will say user says equal to input, and I'll say enter y to print again, or any other key to stop. Okay. Now I'm just checking for small y. Now let's run this again. So what happens? It prints hello. Enter y to print again or any other key to stop. So I'll say y. Goes up, y is equal to y, comes back again. Right? Goes up. Now even if I print capital Y is not same as small y, right? So this becomes false and you are thrown out of the loop. So when this condition becomes false, you get thrown out of the loop. Okay. So this is how you can handle a loop situation. Okay, where you don't know how many times, but you know a condition till user says yes. Okay, great. Now let's say same thing. Okay, let's do it in a different way. See, what did we say? That, while, for even if or while is followed by condition, right? And conditional statement will give you either true or false, right? Conditional statement will give you either true or false, nothing in between, nothing more, nothing less, right? So instead of creating a user says equal to y and again doing the same stuff, we can directly say while true, right? Now, when you do while true, and now I print hello, okay, print hello, hello again, let's say. Now, when I'm saying hello again, while true, right? So is there a way we can make it false? No, because we have hard-coded true, right? If we had a variable, let's say I put a variable here called check or something equal to true, okay? Then I can say check, and I can say here, something like this, and I can say if user says equal to y, then check equal to false, right? So here you have a variable check, and in this line, in line number 11, we are making it false. So whenever line number 11 executes, this will stop. The loop will stop. Okay, if this condition never becomes true, then it will go on forever, right? No, sorry. If it is not equal to y, right? Because equal to y, you want to continue again. If it is not equal to y, that's when you want to stop it, right? So let's say here, okay, this is the first one, hello, right? So here I'll put something else. It stops here. Hello again. Enter y to print, okay. So let's say I put y here. When I say y, this becomes false. Y not equal to y is false. So this part will not get called. So directly it will go up. And what's the value of check? It's true, correct? So hopefully it will print hello again, right? So keep giving y, it keeps on printing hello again. Now when I give anything other than y, okay, let's say n or blank or something, now n not equal to y becomes true. Then you get it, check equal to false, and then goes up, this becomes false. So, no way your loop is going to run. Okay. Now, there's one more option. We don't have to write extra 3 lines, okay? Loops, and this can be used in for loop also. Let me do it again here. So I'm going to say check true, okay? And hello again, okay? Now, instead of saying check equal to true, let me put true here itself, okay? So this is hard coding, right? So there is no way you can change the value. What I can do here is, I will say, okay, user says, okay, and you can say here, if user says not equal to y, you say break. Break is a command which will throw you out of the loop. The moment you hit break, it will throw you out of the loop. Okay. So now let's run this again. This is hello. So I'll say n. Okay. Hello again, n. Now you say hello again, and y to print again, or any other key to stop. So I'll print y, hello again, right? Any other key, b, and break will throw you out of the loop. Okay. So we have just seen, same example in 3 ways, right? Obviously, in this case at least, this is preferred, right? How many lines of code we have? 5. Okay. 5. This is also okay. This has only 4 lines of code, right? So probably here at least this looks better. You have only 4 lines of code. Here you have 5 lines of code. Definitely this is little lengthy, 6 lines of code. Any questions? I'll give you 30 seconds to think. Go through these examples and ask me if you have any questions. Which line number? Where? No, tell me the line number. No, then only I'll know. Tell me the line number. Line number. 14. Huh. Entered N. Anything other than Y? No. Anything other than Y. Y is to continue. Anything other than Y this will be true. N not equal to Y, B not equal to Y, A not equal to Y, Z not equal to Y, blank not equal to Y. You don't have to enter anything. You can even enter blank also. Blank is also not equal to Y. Right? So, you want this condition to be true to stop, right? If this condition is true only, this will stop. Break will get will be executed. So when do you make this true? When they are not equal. If they are not equal only, it will become true. So anything other than Y, this becomes true and you will break it. Uh-huh. Which line again? You tell me that I'll you understand. See here, okay. So depending upon your situation, okay, we have something called as entry controlled and exit controlled. Now, in all three examples, okay, in all these three examples, you need to print hello at least once. Okay. So, you know, the way this is designed is hello will be printed at least once. Okay. At least once. Now, I'll just move these away. Okay. And I'll show you another example where you don't have to print even once. So we'll come back here. Let's take first example itself. I'm going to delete all these. So here, instead of checking it here, okay, you can directly put this one here. Okay, we hard coded in all the three. In a way, we hard coded in all the three, right? Because we wanted to print hello at least once. Now, in this case, you're checking before you enter into the loop. Now, here itself, if you say no, right? If you say here itself, end, okay? So, you know, this becomes false here. So, you're not getting in, right? So, that's how it is. So, you are not checking, or what you say, you are controlling the entry. Okay, so you know when you go to a movie theater, okay, there could be two types of um, you know, the way they check your say ticket, right? One is they'll check you at the entrance. And if you have a valid ticket, you go in. So now what we did is we are checking at the entrance itself. If you have a valid ticket, you go in. Okay, right? And in this case, what we are doing is while true, that means door is open, you go in, you watch the movie. But when you're coming out, that time I'm checking your ticket. Like when you travel in a train, metro, or not metro is again entry check, right? Movie theater is entry checking. But when you travel into a train, they don't check your ticket while entering into the train, right? They'll check it while you're inside, you know. While you come out, they will check your ticket. So it's something like that. Yes, the way you want to implement it. Now, in other languages, Java, C, C++, you have something called as do while loop. Okay. Do while is like your exit control. So do is like while true. Then you do keep doing it, and when the condition becomes false, you are thrown out. Okay. Condition becomes false, you are thrown out. But in Python, you do not have do while. Okay. Python tries to make things as simple as possible. So what Python says is while and do while, they are very similar. So why should we have one extra thing? Just remove it. You don't have to learn one new topic. But in all the other languages, okay, whether you talk about Go language, you talk about Python, sorry, um, Java, C, C++, all those language has do while. But Python does not have do while. This is like saying do while. That means you are not checking the entry. You go in, but I'll check you when you come out. So if you do not have a valid ticket, then you're stuck in the train forever. Okay, that's what. So yes, you can do hard coding, or if you do not want to do, you can do something like this as well. So in this case, it's possible that hello is not printed even once. But in the other three examples that we did, we made sure that hello is printed at least once. Okay, so it depends upon your situation. Now see, we are just focusing on while. Okay, it's like focus on while. So, but in real, you know, program, you will see something else before while, right? That's how you come to while. So, you know, it helps that way. Correct. Yes. Okay. Your objective has to be to, yeah, to do, you know, as with minimum code as possible. Correct. Exactly. That's how you do it. Yeah. So, I generally give this example. Okay. I'll just show you another example. And for loop example, let's say I want to print multiples of 11. Okay. Between 1 and 100. Okay. Multiples of 11 between. So you have 11, 22, 33, 44. Right. So I'll say for I in range, you have 1 comma 100 comma say 11, right? Or we'll start with 11. So we'll say 11, 100, 11, right? Now when you print it, okay, so you print I and I want to print them in one single line. So I'll say end equal to, I want to have a comma in between. Okay, so I'll put comma here. Okay, so let me move this away. Okay, and let's say you run it. Okay, so you get this 11, 22, 33, 44, all this fine. But let's say I want to get rid of this last comma. How do I get rid of this last comma? So what should be the logic? You tell me the logic. What should be the logic to remove this last comma? Forget about the programming. But how do we know number of times? And we cannot give number of times, right? Because comma should be after I. So you print I, comma, then print I, then comma. It should be together. You can't print all I's together and then put all commas together. Okay. So I need to somehow know that this I is the last value. If I know that this I is the last value, then comma is not required. Somehow I need to know, right? I need to know this I is the last value. Okay. And if I is the last value, then I will not print. So it's something like this. Okay. If, and this is not Python code, so I'll put it in a hash. If I is not the last value, then print this, right? Else you print, okay. PyCharm is smart, does not see any if, right? That's why it's pushing it outside. Okay. If it is last, then you don't do this. Correct? Or in a way, what I'll say is, if I is the last value, print this. I mean, and then in that case, you don't need end. Print I. If I is the last value, print just I. And if it is not the last value, then you print comma and space. Right? Okay. Now, how do you figure out this is the last value? So let me do one thing. I'll put all these three variables with a variable name so that I can have access to those. Yeah. Starting is 11, 100, ending is 100, and increment is, yeah. So we'll say counter or something equal to 11. So you say 11, 100, 11, and here we'll replace with these values, okay, with variable names, so that I can have access to this, yeah, while checking the condition here. Okay. Okay. So how do I figure out? Okay. So let me do it this way. If, okay. Now, and modulo, okay. So if I equal to and divided by co, right? So if I divide 100, end is 100, right? 100 divided by 11, what do you get? Huh? Look at the sign. What sign it is? Integer division. Yeah, so integer division will not give you remainder. So what do you get? 100 divided by 11. What do you get? 9. Yes. So I'm saying if I equal to this, right? Then that means that is the ninth value, right? Then you print I. Okay. Otherwise, you print this. Okay. Now what I'll do here, okay, let's do with this. Okay. Did not work. Let me make it 99. Will it work? No, it didn't work. Okay. But if I make it 102, oops, no, wait, hold on. If I is, okay. Now see, I will be 11, 22, 33, 44. I is not going to be 1, 2, 3, 4. So if end slash co into st into st. So if I run this, so see, now you do not get space. If I do it 100 also, you will not get space. But what if I make it 99? You get it. Because 99 by 11 is 9. And so this, your I will never become 99. No, 88, no. So this will not be 99 ever. So it is, this condition is failing. That's why for 88, it's not showing. Okay. So if it is a perfect divisible of 11, okay, you will have space here. Otherwise, okay, for 100, it will work fine. Right? Okay. Now, so what I should do is, I need to check for this or I equal to something, okay, when it is perfectly divisible. Okay. So what happens? This is one case. So before this, okay, I need to check if this ending divided by CO is perfectly divisible. Right? Okay. So something like this. If end modulo co equal to 0. And modulo co equal to 0, that means divisible. That means it is 99 here. If 99, then it will be divisible. In this case, what I need to do is, I need to check for if, okay, if, now see here, I need to check for this one minus 1. That means here it will not be 9, it will be 8. Then you print I. Else, you print this. Okay, and then this is for not divisible, and this is for if it is divisible, then you know this, you know. So this is when it is not perfectly divisible. It is not 99. So we have already tested this. We have already tested this. Now what I'm doing here, if it is perfectly divisible, then I'm not checking 99 by 11. I'm checking 99 by 11 minus 1. So 88. So now when you run this, so see, you got for 88, right? And if you make it 100, you get 99. Okay, right? Now let's see one more example. Okay. The approach here was to check if I is equal to the last element. And to find the last element, we had to do so much of breaking our head, right? Second way is simply to know, okay, if I plus co is greater than equal to end. What does that mean? If I plus co is greater than equal to end, that means this is the last value. Yes or no? Okay. If it is 88, 88 plus 11 is 99. And if you put 99, then it is equal to, right? So last value. So if it is last value, you print I, okay, and then else print with comma, right? Now both does the same thing. Here, it depends upon your approach, what you are thinking at that point of time. Okay, where was your head, right? Sometimes you will hold your nose by twisting your hand, right? This is the same thing, and this is simple. Okay, I don't need to know. See, here my approach was, I'm trying to figure out if it is last element or not. Here my approach is, okay, if the current value plus counter is more than or equal to the ending, that means this is the last value. So I should not exceed the ending value. Which one is easier to do? Second one, right? But same logic. It's the same logic that we did. It depends upon your approach, right? So that's why what we say generally is, if you are, and this happens in personal life also. When you have a problem to solve, okay, and you get an idea, don't jump with that idea. Always think of other alternatives, second or third alternatives. Always have at least 3 alternatives before you take. Maybe the first idea might be the best one, but do not jump to that without testing it against second and third idea. For every problem that you solve in programming world or in your real life world, have 3 solutions. Always. Even if you get first idea, hold on. Look for second and third solution. Then you compare and say, okay, first was better, or second was better, or third is better. 50% of the time, first would be better, but still have 1 or 2 more approaches to think before you start your solution. Okay. Any questions so far on this? No, keep thinking. No, your brain will only give you. Okay. The problem here, okay, what I see is our brain thinks very fast. We don't even know how our brain thinks. Okay. Since we don't know how our brain thinks, we are not able to catch up. Okay. So one more example, let's take. Now, let's say I want to figure out between A, B, and C. Did we do this in the class? No, I don't think so. No. Find the highest value among 3 numbers. We did, right? Ha. So what I was trying to say is, it is how you think. That's what we're trying to implement, right? Okay. So, okay, first compare A, B. Now, if I give you A comma, B comma, C equal to 10 comma, 30 comma, 20, I'll ask you which is the highest? Immediately, 30. But tell me, how did you think about it? How did you arrive at 30? Don't know. No. Slow down your brain. Brain gave you 30 answer. No. How did brain give you 30? Compared. Exactly. Brain compared. Slow down your brain. Slow down your thinking process. To slow down your thinking process, you will get the steps which brain did. Same step, you have to put it on the programming, right? Same step, you have to put it on the paper or on the laptop or in your Python. Yeah, you only train the brain. Now brain is out of control, right? You only trained your brain, but now your brain is out of your control. You have to control your brain. Okay. Any questions so far? All good? Ankit, Karan?
Yes, it's all good.
Perfect. Okay. So we'll do a couple more examples. Okay. So I spoke about break, right? What does break do? It will throw you, yes. So see, if you have multiple loops, okay, or nested loops, the the place where you put break, that break will throw out from that position itself. So if I have while, okay, and I have while again, and I have while again, okay, now if I put break here, this break will throw me out of this inner while and place me at this while. So you are out of this while and you arrive at this while. Now, if I put this break in second while, now break is in second while. So this break will throw me out of this second while. So I will go to this first while, right? So I'll be still inside the first while loop. If I put again break here, now when I encounter break, I'll be thrown out of the break. I'll be somewhere here in the main. Okay. Now, break works with both while and for loop. It can be for loop also. Okay. So it doesn't matter for break. It is for loop or while loop. But it is used only with the loop. Okay. It can be for loop or while loop, doesn't matter. But it will be loop only. Okay. And it will throw you out of the loop. So let's take another example. Okay, let's take a case where you enter a number. So num equal to int of input, enter a number. So I'm taking a number and I will try to create 10 multiples of this. Okay. So for using 10 multiples, okay, I can say for I in range, right? 1 comma 11, right? That's what we did before. And here I'm going to say print if num into I also in curly braces equal to num into I, let's say. Okay. So on this program, if I say 6, you get table of 6. Now let's try to add some condition. Condition is, okay, write a program to find 10 multiples, 10 multiples of given number. This is what we have done. If the number is less than, or if the number is negative, let's say, if the number is negative, okay, then do not then do not process or do not execute. Okay. So if number is negative, so before I perform for loop, I need to check if num greater than 0 says negative. See, negative 0 is also not negative. In this case, it will be num greater than or equal to 0. If I say only positive number, if I say perform this only for positive number, then I'll go with num greater than 0. It says do not perform for negative numbers. That means you can perform for 0 also. So I'll say if num greater than equal to 0, that's when you perform this. Okay. Now let's add one more condition. If the number is multiple of, okay, if the multiple is multiple of 12, if you come across multiple value as a multiple of 12, then skip it. Okay, skip it means I don't want to print that. Okay, and then, but the next one I want to print. So if you take 6 example here, this is multiple of 12, right? So I should not be printing. So we have something called as continue. So you have break and continue. They are used only with loop. Break will throw you out. So loop will end. That particular loop will end. Continue will take you to the beginning of the loop. So if you come across continue, you will not proceed further down. The moment you hit continue, you will not go down. You will go up to the beginning of the loop. Okay, it's like this. You're going to your office and then you see a continue button. Then you come back to your home. You will not go. You'll come back to your home. Okay. So before I print here, correct? So I'll say if num into I. Okay. If num into I, okay, I can do it in 2 ways. If num into I, okay, modulo 12 we said, right? If 12 not equal to 0, then do this. Correct? So if it is not equal to 0, so if you're calculating num into I and checking if it is not divisible by 12, okay, then you print this. But if it is equal to 12, then you don't print it. Correct? Then, so this is another way to do it. So I'll say 6. You see, you get 6, 18, 12 is gone, 24 is gone, 36 is gone, right? Or, I'm just showing you different ways. And in your program, depending upon what is right, what seems fit there, you should use it. I can say here, if this equal to 0, if this is equal to 0, then continue. And this print is part of the main program now. Okay. So for loop, it'll enter. And if this conditions becomes true, continue will take it to the beginning of the loop. Continue will take it to the beginning of the loop. So whatever is down below is not even touched. Okay. So now when I run it, okay, if I give 6, you get same output. So I'm just using continue. So if this is equal to 0, continue. That means don't go down, don't do print. Yes, and it goes up to the beginning of the loop. Okay, I can say here, if, okay, you come across multiply the value as a multiple of, okay, multiple of 20, then stop it. Right? So simply I will say if multiple of 20, right? If num modulo 20 equal to 0, then break. Break will stop my program. Right? So now if I run it, if I say 6, okay, it's going fine. Now when I run it, okay, and I say 4. So see, 4, 8, 12 is not printed because 12 is multiple of 12. 16, then 5, 20. 20 is again multiple of 20, right? So it stopped there. It's not going forward. It's just stopped. It didn't skip, it stopped. Now what I'm saying is perform all this till user says yes. So this entire thing I need to perform till user wants to continue. Okay. So what I'll do, I'll put a while true here. Simple. And I'll move all these inside while. One step inside. Okay, you can select and you can say tab. Select all these and say tab. So everything will move one step inside. So while true, now it will go on forever. We need to have a stopping condition. Okay. So I will say here ch choice equal to input hit and to, okay, hit any key to stop. Hit any key to stop. So if I want to stop, I'll say A, B, whatever, anything. So how do you check this? If len of ch. Now len is another function. How many functions we have discussed so far? How many functions have we discussed so far? Name. We have discussed more than 5. 5 is those basic type only. Int, float, those are 5. Apart from that, we have to print, input, type, correct? So this is another function len. Len will tell you the length, how many elements are there in this. So if I enter A and hit enter, that means it has 1 value. If I say ABC and hit enter, it has 3. So what I'll check, if len of ch is 0, that means you have not hit any key, right? So if len is not equal to 0, then you break. If it is equal to 0, keep doing it. So let's say enter a number. So I say 4. Okay. Hit any key to stop. I hit nothing. I did not give anything. Okay. It continued. Okay. Enter a number 6. Okay. Then enter a number 9. Okay. So you go to all these, right? Now if I put anything, A, B, C, and hit enter, it stopped. So you're checking the size of CH. If size of CH is 0, you continue. Okay. You put any key, the length will be more than 0. So that's when you stop executing. Okay. So this is where you can use while. So you are checking the input from the user. Okay. One of the biggest application of while is to generate what we call as options, user options. Okay. So when you log into many of these applications, it'll tell you, okay, what do you want to do? Do you want to, add to number, you want to, let's say you'll take library example, for example. So in library, you'll say, do you want to add books to the library? Do you want to take book, issue the book from the library? You want to return the book? So you have many menu options, right? ATM also, exactly. Okay. So that's where while is used. Okay. So we'll try to do ATM thing. Okay. Let me move this away. So let's take ATM example itself. Okay. ATM transaction. So we'll say while true, right? You are entering into an infinite loop area. And I'll say enter your choice from below menu, something like this, let's say. Then I'll say print 1 dot deposit, right? Slash and 2 dot withdraw. Okay. Then slash and 3 dot account transfer. Okay. Slash and 4 dot statement. Account statement, right? And then slash and 5 dot quit. Okay. Now I'm going to say ch equal to input. Now see here, though the option is number 1, 2, 3, 4, but it doesn't matter whether they give you read one as integer or string. We are not going to add these numbers, right? We are not going to perform mathematical operations on these choices. So they usually give you either 1, 2, 3, or 4, or even 5, right? So when you take these values, we are not going to perform any mathematical operation. So there is no need to convert into integer. You can directly read them as string. Okay. So enter your option here. Okay. Now you can build series of if else. So if ch equal to 1. Okay, we'll say pass for now. Elif ch equal to 2. You say, sorry, 2. We'll put the logic later. We'll say pass. Elif ch equal to option 3. Okay, pass. Elif ch equal to option 4. Pass. Elif ch equal to option 5. Pass. Okay, 5 options, right? So we have got 5 options. Now I'm going to say else. Else means outside those 5 options. So I can say here print invalid option, please try again. Right? Please try again. Now it should go back to the beginning, isn't it? So I'll say continue. Okay, option 5 is break, right? So option 5 is to stop it, right? Quit. Right? We need to quit. So I'll put here thank you for banking with us. Yes, have a good day. Okay, and I'll say break. Okay, so now if you see, if you run this program, what happens? Deposit, withdraw, account transfer, statement, quit. Okay, enter your option here. My option is 1. Anyway, we have not built anything in the 1. So 1 is performed, goes back again. Okay, I'll say something which is not there, T. So T, invalid option, please try again. Okay, I'll say 7 or 8. Invalid option, try again. And where now I'll say 5. Okay, quit. Now you can go back and you can put your logic here. So when we do functions, you can put a function here, or for now you can say print enter the amount or whatever, right? You can continue with the logic. Okay. So you can build upon it. I just wanted to show you how this works while we'll work. Yes, tell me. Yeah, you can give your input here. No. Yeah. Of course you can do it here. Right? The logic not ready, logic not ready. I'll put this one itself here. Okay. Okay. So this while is used to build your menu options, and that is infinite loop. Okay. So again, there are a lot of examples you can see. It's already 34. Okay. I wanted to show one program. Let's do that program. Okay. We'll probably build half now. And then we are not meeting for next 2 days. Okay. Tomorrow and day after, I need to go to office early. By 7 itself, I'll have to leave home. So we will not have. Okay. Instead of doing half an hour of session, that didn't make sense, right? So, any question, guys? Ankit, Karan? No?
No, sir.
Okay. So please, you have 2 more days. Please practice. And on the Thursday, you ask me if you have any questions. Okay. Okay. So the next program, we'll do one more program and we'll end the day. Okay. We have seen continue and break, right? Okay. Let's do a program to print prime numbers. Okay. And assignments, you can try Okay, the first program we can say, write a program to generate first 5 Fibonacci numbers. What are these numbers? It's like 1, 1. So first value is 0 and second value is 1. And the next value would be 0 plus 1. So you can start from 0, okay. So 0, 1, and then the next value is sum of previous two number. So next value is 0 plus 1, 1. What will the next value be? 1 plus 1, 2. Next, 3. Next, 5. Next, 8. Next, right? Next, right? So on. So take this as variables. So if I say 5, it should give you 0, 1, 1, 2, 3. Okay. If I say 10, it should give me 21 plus 13, next value, right? So if you keep changing this, it should keep changing the output. Okay. So this is one example that you can try on your own. Okay. So now we will work to generate prime numbers. Now, before I generate prime numbers, we'll write a program to check if a number is prime or not. Okay. So let's say if you have num equal to 21, and I want to check if this is prime number or not. So how do you check if it's prime number or not? That number is divisible by 1 or by itself. No other number should be able to divide it. Okay. So if I perform a for loop for I in range, okay. So I'll start from 2, not from 1 or 0, because 1 and 0 will always be divisible, and go up to num minus 1. Okay. And we'll try to improve on this. So num minus 1. So I will go up to 20. Or in fact, to go up to 20, you don't have to say num minus 1. You have to just say num, because range will take care of minus 1, right? So if I give num, it will not go up to num. It will go up to num, right? 1 before num, right? So I don't have to say minus 1. Num is enough. Now, before you enter into the loop, we'll assume that number is prime. Okay. Now see, most of these values will not be able to divide. Some values will only be able to divide perfectly. So we'll assume that this number is prime. So sometimes you have to assume something and then disapprove yourself. So in this case, 21 is obviously not a prime. So I will assume myself that it is prime. Okay, see. And this is how, when we do data science later, we'll see that this is how we check any logic or any condition or any theory, any hypothesis. Okay. If I tell you, if I give you one statement that all apples are red in color, I tell you all apples are red in color. Now, if you show me even one apple which is not red in color, then I will accept my defeat, correct or not? Because when I say all apples are red in color, if you show me I have red apple, you are kind of approving what I'm saying. If you show me one green apple, that's when I will change my statement, right? So same thing. This is how hypotheses work. You make an hypothesis and then you work to disapprove itself. Even if you get something which is wrong, which is not what you have just said, according to what you have said, you will stop, or you will take back your words. So here I'm saying that assume is prime is true. That means I'm assuming that num21 is prime. This prime is a variable, right? Right? It's a variable, right? Let me make r small. So I'm defined is prime, which is a variable. Okay. Generally, we don't do like this. We say underscore. Okay. General best practices, do not put capital letters. Okay. You put underscore and something like this. So I'm saying is prime is true. So what I'm saying is the number that you gave me is prime. Now I need to disprove myself. If I'm able to, then I will say it is not a prime. But if I'm not able to disapprove myself, then it is prime. So for I in range 2 to n, okay, divide if num modulo I equal to 0. That means I is able to divide num. Then my assumption is wrong. Okay. And last, outside the loop, I will check if is prime, then print num is a prime number. Okay. Else you say that num is not a prime number. Correct? So when I run it, 21 is not a prime number. Right? If I make it 23, it is a prime number. Okay. Now you see this here. Now, the moment you know, let's say 21 itself. So first it will check with 2, not divisible. Fine. It will check with 3. 21 is divided by 3. So this becomes 0. So we know it is false. Correct? Now, once we know it is false, we don't have to go and check for 4 or 5 or 6. Okay? So we can give a break statement here to avoid checking. So see, the number of steps that you will take, okay, is unnecessary more. Once you know the answer, why do you want to continue? In cricket, when somebody wins the match, T20, if you win in 18th over, you will not say, no, I also want to play 2 more overs, right? Once you know who's the winner, you stop it. Once you know that this is false, you stop it. You don't want to continue. So you can add a break here. Okay. Otherwise, you'll keep on checking till the last value. Now, let's take 21 itself, right? The minimum that you need to go is probably half of 21. Because see, if something is not divisible, like 100, let's say, 50. If it is not divisible 50 or 50, it will definitely be not divisible 51, 52, 53. Because after 1 comes 2, right? So I'm making it half. The minimum lowest number is 2 into 50 for 100. So if it is not divisible by 50, then it is definitely not divisible by 51. I mean, you cannot divide a number with something more than half of itself. So I don't have to go up to n. I can simply say 2 and maybe add one more, because to check up to 50, I have to go for 51 to check for 50. So you are again reducing the number of iterations that you are doing. Okay. Somebody even said that, I read somewhere, that even square root also is possible. You don't have to check for half. You check for square root. If 21 is there, what is square root of 21? 4 into 4 is 16. 5 into 5 is 25. So it says you check only up to 5. You don't have to check for more than 5 also. If it is not divisible by something less than 5, then it is not divisible at all. Okay. So 21, obviously, 5 if you check, 3 is divisible with 3. You don't have to check for 7 or something else, because 3 is what you have already seen. So you can also give square root plus 1 here. Okay. But let's say you say divisible by 2 plus 1. So this is how you can check if a number is prime or not. But what was our question? Our question is to generate a prime number. Okay, prime numbers between 5,000, 5,000 and 10,000. Okay, so instead of num, it should be 5,000, 5,001, 5,002, 5,003, so on. So what I'll do, I'll put a for loop here, right? For num in range 5,000, comma 10,001, right? And all these things will move inside. So what I'll do here, let me copy this, okay, so that we have a copy of this. Check for prime. Okay, now here, okay, so we know that it is prime. Once we know it is prime, we don't have to say is a prime. we just have to print it, correct? So else is not required, and here you just print num. That's it. And if you want to print in same line, okay, you say comma and equal to. That's it. Now if you run it, it should actually generate a indentation. Why indentation? All these things have to move inside, isn't it? Everything has to move inside this. So now these are your prime numbers between 5,000 and 10,000. Okay, so I've used the same logic of checking a number is prime or not and putting that in the loop. So loop is checking again and again and again, and if it is not prime, it is not printing. If it is prime, it is printing. Okay, any questions, guys, on these, what we have done so far? If no, we will stop here. All right.
Yes, sir.